This conference will now be recorded.
Hello everyone. So today our topic is going to be Pandas Library. It is a very interesting and most widely used library while dealing with tabular data. So we need to install Pandas Library similarly the way we had installed NumPy. So there is no difference while installing the library because we usually don't get it explicitly while installing Python compiler. So in Pandas, first thing which we have is a series. So just like NumPy, series is also an array, but it can have explicit indexes. By that, what I mean is NumPy has only numerical indexes. In series, you can provide string as indexes as well. So I'll show you how it looks like. So suppose I have this data, these numbers list I have, and I have the list of characters as well. So on printing the first series by using this function pd.series, it is used for creating series, and I gave my numbers list as the data input. So here I have my data with the normal numeric indexes. I can explicitly allow it to take the characters as indexes as well. And then this is how I'll have my series generated. And for short notation, I can ignore the keyword arguments as well and just give my parameters. This is just for ease of writing the code and nothing else. Now, how can we create these series and how to work on it? So this was one of the ways of creation of series, which was the list method. We can also create it using NumPy array dictionary. So suppose I have a NumPy array ARR. So this is my NumPy array. I can directly pass it as a parameter while creating the series, and I can have the series generated. Similarly, I can pass the second parameter as my list of characters, and I can have that as characters as my indexes. Now we can also generate it using dictionaries. So in dictionary, I have my key value data, and I can just directly pass the dictionary, and the series would be generated for me. So the keys are taken as the indexes, and the value is taken as the column value. Now here are a few other examples which I'll show you. Like in NumPy, when we add two arrays, we get the element-wise operation generated output. So by element-wise, I meant that if I am going to add two NumPy arrays, suppose this is a NumPy array and this is a NumPy array as well. So element-wise, suppose I'm doing addition. So element-wise addition would be done. So this would be 23 plus 23, 56 plus 53, and 34 plus 78. So similarly in series also, we have the same functionality available. So I'll just generate the series first. Oh, sorry. Yeah. So I have my first series and I have my second series. Both of the series have A and B indexes, but the third index are different for both of them. So if I add both of them, so you can see that A and B got the result as element-wise addition, but for C and D indexes, the answer is NaN. That is because here D label has 34 as the value, but the second series does not have any value for that label. And similarly, C has some value here in the second series, but the first series does not have any numeric value with respect to that. So the answer for these two have come out to be as NaN. Yes, definitely, Arun. It will only do the operation on basis of the indexes. So here, as my indexes are labeled, by labeled I mean that they are string and not integer. So that's why it did the operation on the on those labels which were matching, and for ones which were not matching, it gave an answer as NaN because there is no value for that label present in one of the series. So if there are any other doubts, you can write in the chat. Otherwise, we'll proceed with data frames. Just one point I would like to add is that before heading on to data frames, I wanted to teach you guys series, because series is just like a single column of a data frame. So if you access, I'll show you in the later here. If you access a single column of a data frame, it will give you a series. So that's why now we'll start with data frame. So similarly, we can create data frames as well from list, dictionaries, and all. And I have a data frame which will be generated from a 2D matrix or 2D list. I have named it as matrix. So we have a function called as pd.dataframe. Actually, this is a class, data frame class, and we will pass our matrix. We can also indicate what indexes we want and the name of the columns. So this would generate a data frame for us. So you can see that it took the column names as we specified and the indexes which we had specified here. And similarly, it has taken data. So this is the first row, this is the second row. Similarly, this is the third and fourth row. So that is how our data frame has been generated. So if I just use the type function, you can see this is the class. So this is a data frame class, as same as series. Series is also a class. And if I try to see the type of one single column, so for accessing a column, we specify it in the like we access it using a list or an array. Similarly, we can do that in data frames as well. So this allowed us to have the values of the column C1 to be printed. So now if we see the type of C1, you can see that we got the type as series. So that is what I was telling, that a single column of a data frame is a series. Now we can also have a data frame created while reading it from a CSV file, because most of the times our data is in Excel form or CSV or JSON. So all those parameters are available. I'll just show it to you. Yeah. So we have these all functions. We can have Excel, CSV, JSON, Parquet also is available. And for now, I'll just discuss it with CSV. I don't have examples for others as well, but you can take it as a self-learning example. So here, two methods are there for accessing a CSV file. So in my D drive, I have the file called as sample.csv. So I'll just make use of the function read underscore CSV, and it would generate the data frame from it. So we can also make use of the second function. The only difference between these two is that while giving the complete path of the file, here I'm using forward slashes. So that's why I had to use another forward slash as an escape sequence. Uh, Otherwise, both of those methods work completely fine. So here I'll just show you a simple example of accessing the data. Now we have another way of accessing a particular column of a data frame, which is this method. So Earlier I had shown you this method. Now this is also one of the methods, but it is not preferred because it can lead to confusion for the developer that whether this is a function call or is it a name of the column which we are accessing. So generally we use the first as a standard for accessing a column of a data frame. And now there is one more thing that in data frames the name of the column must be known, otherwise we might face errors which says key error. So we must know the name of the columns, otherwise we'll have to face errors such as these. So this is a must. And we can also access more than one column by using this notation. So this way we can have two columns data access to us. Now, is there any doubt? Otherwise, we'll head on to creation and deletion of columns, and you'll get to know more about accessing of data if you have any confusion about that. Yes, Arun, you can ask your doubt. Arun, are you there? While reading external data, does / also help through C drive, like path/user? Yes, it will definitely help you through C drive. Uh, the drive is not any exception for that. There is only one thing which I wanted to mention at that time is that we generally have /n as an indicator for, sorry, we generally have /n as an indicator that it denotes next line. So in that cases, the slashes needs to be escaped for us. So that's why I told you that we can use both of the notations. But it's only dependent on your way of coding, which one you want to make use of. You just need to escape the slash if that generates as a new escape sequence for you. Okay, so let's head on to the creation and deletion of columns. So as I already told you, a single column of a data frame is a series, and we've already done a simple operation of series, that was addition. So similarly, we can add two series and have a new series generated, which can act as a column, a new column for our data frame. So suppose this was my data frame. Now I did the series operation and I got this new column generated for me. So you can make use of the data frame operations itself for creating a new column, or you can explicitly give some data. So what this operation will do is it will give hello as a value for all the rows of the column C7. So as you can see, hello has been given to all the rows present. And if you want to drop any column, there is a method called as drop for a data frame. So in that you will specify the name of the column and you will specify the axis. Now axis is something you define which by 1 it means that it's going to drop a column, and by 0 it means that it is going to do a row wise operation. So since I want to drop a column and not a row, that's why I've mentioned axis 1, and by default the axis is 0. So if you want to do a row dropping, then you might not even need to specify the axis. Now drop, what it does, it gives a view of the new data frame which would be generated after dropping that row or column which you have specified. So it does not make the changes in the original database, but it will give you a view of the new, oh sorry, not database, data frame, but it will give you a new data frame generated out of it. So you can save it to a new variable and you can just see the values. Now, in case you don't want to make change to have a new data frame generated, which means that you don't want the original data frame to be kept, or you don't want to have the original data frame anymore. So we have a parameter named as in place, and if you specify true to it, then it will make changes to the original data frame itself. So we'll just head on to that as well. Before that, I'll show you the operation doing on a row also. So here I'm dropping a row R1, and the resultant will be the deletion of that row. And here our C6 column had been dropped off. So this is why axes are important. You can actually remove this axis and specify it, because by default it takes the axis as 0 only. And yeah, so if you don't give indexes while trying to create a data frame, it will take your default indexes, and your default are those numeric indexes, which is 0 1 starting from 0. So specifying indexes is not a mandatory thing. And you can also then drop your rows or columns, or you can also drop more than one row at a time. So here you can see that I have dropped more than one column, so more than two rows, more than one row, sorry. And we can yeah, so this is the in place one, where we do not have to make changes, we have to make changes in the same data frame. So here dif1 we did a drop of column C1, and here we have the same data frame with the updated values. Similarly, we can do the same for a row dropping operation as well, and our original data frame will have the changes made into it. So any doubts regarding this? Okay, so we'll head on to the accessing of data of a data frame. So earlier we had discussed, like, we can print a column of a data frame using this method. This one is not preferred that much, and we can also have more than one columns actually accessed at a time. So to add more features to it, we have uh, operations such as we have a LOC function and we have an ILOC function, which are widely used for accessing data. I'll just explain these two and then I'll let you know the differences between the two. Apart from these two, we also have one IX method, but it is a deprecated method, and we'll also discuss why it is not used anymore or why it should be avoided. So here we have our data frame, and I'm accessing my data of a single column and of two columns, and I can actually make use of slices as well. I think I made a mistake here. Okay, never mind. I'll just discuss that while showing you LOC. So you can see that here I was able to access the complete columns, right? So what if I want some accessing of data which I want to access only certain rows or certain columns, or a certain part of a column I need to access. So and for that, these two methods, the LOC and ILOC method, come into place. So I'll create a data frame. So this is my data frame, df, a simple data frame with 4 columns and 4 rows. Now LOC uses indexes which are defined. By that what I mean is that here you have defined your indexes to be strings, and that's how the LOC works. So both ILOC and LOC follow the row comma column method, but here in LOC we specify the first index which needs to be accessed, and then we can give a column and specify the column as well. We can give a comma and specify the column as well. So this is how I'm able to access the first row, which is this, using LOC. And if I want to access only a certain value, I can give the value of the row and the column as well. So here it went to row R1 and accessed column C3. So here I got the value as 2. So I can have specific data accessed using LOC as well. Now here the slicing is also supported. So you can have multiple data accessed as well. And the other example is this. See, so here I was accessing C1 to C3, so I got these values for my row R1. But when I used slicing like this, then it failed. It failed because C4 is a column which is occurring after C3 and not before it. So the slicing did not give me any value. As you can see here, yeah, the slicing did not provided me any value. So while slicing, you'll always have to keep in mind the order of your columns and rows. So you can also have slicing of your rows as well. So here you have access 3 rows, R1, R2, R3, and column C1, C2, C3. So one thing you must keep in mind is that in our previous classes, while we were learning about slicing, for example, I have this list. I always told you that if I try to access using slicing, then it would take the first element from 0 and the n minus 1th element. So here 0 was 0th index element and first index element was taken. So 0 and 2 minus 1, 1. These two elements were taken. If I give it as 3, I think you will be able to understand it better. But here you can see that I have specified R1 and R3 and it displayed the values including both of them. So this is one of the differences which you must keep in mind, that here while slicing, both of the values are inclusive. So here C1 and C3 were also included. So this is one thing which you should keep in mind. Any doubts while operating on LOC? Otherwise, we'll head on to the ILOC. Okay, so just let's head on to ILOC then. And this is one thing which I forgot to mention. You can also access certain rows and certain columns. So here I had given a slice. Okay, Abhishek has a doubt that for LOC, always do we need to provide index or automatically it will take? No, for LOC, you'll have to always provide the index because it won't take it automatically. So the first thing which I had to mention was the index itself. You can also try this. I'm not sure whether this works or not. Yeah, this does not work. So You can, yeah, for accessing a column, I think you'll have to always provide the index. So without the first index row part, you cannot actually head on to the next part. But yes, you can definitely have a lot of filtration of your data. So you can have a single row access, you can also have a single column accessed, you can also have a single cell. By that I mean a single value of the data frame accessed. And lastly, I wanted to tell you that you can access particular rows and particular column values as well. So here I had mentioned a list of particular row which I want to access and the list of particular columns I want to access. So using that, it has presented me the data. For row 1, I have column 1 and column 3 values, and for row 3, I have my column 1 and column 3 values. Okay, yeah. So let's head on to ILOC then. So ILOC is used when we know the position of the data. So unlike LOC, which uses the indexes or maybe the labeling of the indexes, ILOC will access the data using the position of the data. So if you're getting confused, I'll let you know by a simple example that here what we were actually accessing was using the position of the data. So the data at position 0 and data at position 1. Uh, I mean, in the list, arrays, and everything, the indexes usually start at 0. So this is the first position, but actually the index is 0. So that's why positionally it had taken that data. So similarly, we can have that similar feature in using ILOC also. So I'm defining these three data frames. One has a index specified. One does not have any index specified, so it will be taking an index by default itself, which will be starting from 0. And second, I am specifying indexes, but which are numeric or maybe integer data. So this would not be starting from a 0 since I am specifying it. So we'll just have a little look at all the three data frames. So here we have our normal labeled rows. Here we have the default indexed rows. And here we have our indexed rows specified by me as integer only. So these are the three differences of these three data frames. So suppose I try to access using ILOC and I give the input as 2. So I got these values accessed here. So what these specify actually? So just like in list I told you 0 means first position. Similarly here index will also start from 0 itself. And it has accessed the this third row of the data frame. So 0, 1, 2. So it basically third position but the second index. And if I try to access the same for my second data frame, which is df1, you can see that I got the same output because at 0, 1, 2, I have the same values present. And similarly, if I do the same for my third data frame, you can see I got the same values again printed out. I had the index value as 3, but it printed the values using position of the data. So in case you don't care about the labeling of the rows and you just want to access the data according to the indexes or the position of the data on the data frame, then ILOC is used. So this is one of the major difference between LOC and ILOC. So similarly, like in LOC we had slicing, we also have slicing available in ILOC. So it has accessed rows starting from first index. Yes, Arun. ILOC means index location. That's the short form from ILOC. Okay, you want me to explain the syntax again? Yeah. So I had given you an example of list earlier. That suppose I have a list 1, 2, 3, 4, and I give this slicing. Suppose, forget about slicing, I give this. So 0 means the first element. And if I give 1, so that 1 here actually means the position at index 1. Okay. So just like in list, we are accessing using the position of the element in that list. Similarly, we can do that. We can have that same functionality in a data frame using ilog. So ilog, as you have already mentioned, it is index location. It indicates index location, and no matter which kind of data frame I have, my output would be positional based only. So this was my first data frame, this was my second data frame, and this was my third data frame. Now I had specified df.ilog2, which means print the row which is present on the second index. So indexing starts from 0. So second index means third position. So no matter which data frame I use, it will always print the third row of each data frame here. So when I had printed the row present at index location 2 for data frame, the first data frame, which is df, it printed this 8, 9, 10, 11, and the column C1, C2, C3, C4. So it generally represents this. And if I do the same for df1, you can see that I got the same values printed. Even though the indexes for the second data frame, which is df1, was not specified, but by position, this was the value which was present at third position, which is index 2. So the same values got printed. And even if I change this to the third data frame, which is our df2, here I had specified the indexes as 1, 2, 3, 4, not even starting from 0. But even so, it took the third position elements only, and that only it has printed. df2 ILOC for this operation should be. Yeah, Abhishek, that's what I'm saying, that it does not depends upon the indexes which you are providing, right? Here in LOC, while using LOC, I was specifying which index I want to access. So it was hugely dependent upon the index value. But in ILOC, it does not depend upon what your index value is. It can be anything. It will just access the data according to the position of data present in it. You can define, that's what I wanted to clear out for you guys, that you can define string indexes, you can have your own integer indexes, or you cannot define, you can use the default indexes as well, but it will access the data according to the position of the data in that data frame. So here the label of the index does not matter. It can be numeric, it can be string, but it will take the data according to the position of it present in the data frame. So that's why the result of all these three operations will be the same, because the data is same for position wise, the data is same, not label wise. So this is the major difference between ILOC and LOC. Now, as I was telling, that slicing is supported, so you can have your data accessed. This is the index value 1 and index value 3. So here you can see that I have 1 to 3 specified, but only 2 rows have been printed. So this is following the same similar syntax which your list indexing, which I had shown here, follows. See, only 2 values got printed, but in LOC, it will include both of these values. That's why 3 were printed here. So if you have a practice of list indexing, then ILOC indexing is similar to that. So that's why only 2 rows are printed here, present at index position 1 and index position 2. And let's do the printing of the other data frames as well. Yeah. So you can see again the data printed is same because my slicing is the same for the data frames. And as I've already told you, it depends only upon the position of the data, not the index labels. So that's why the values are same. So now suppose we have this data frame df1 and I want to access certain columns. So I can do the same by, this is the same operation, same kind of operation which we did in our LOC, which was the row comma column. Okay, so the way which we had here was row comma column in LOC. We can have the same functionality in iloc as well. So this is accessing your position 0 and 1, index position 0 and 1 of row, and index position 1 and 2 of column. So that's why C2 and C3 got printed. C2 is your column present at position index position 1, and C3 is the column present at index position 2. So similarly to LOC log, you can access particular data using iloc as well. You can give a certain value and you can have a single value as printed as well. So there is no difference of accessing data in LOC apart from the one which I've already mentioned. And you can see that I have the same slicing, and the data is also printed same because it took position of the indexes for accessing the data. So columns also it is going to access by numerical indexing only. That's why the position matters for iloc. Now I've already mentioned you that loc includes the last element when using a slice. So that's why the result here was all three R1, R2, R3. But iloc does not include the last element. So the output for this will be 0, 1, and 2. 3 would not be included here. And it does an indexing on labeled rows, labeled data, and it does the indexing on your position of the data, positional index it uses. Now there are few interesting things we can discuss on both of these. So suppose I have this data frame which has the default indexes starting from 0 to n. Now if I use iloc on this, no, I'm sorry, if you use lock on this, then what will happen? Because I have already shown you examples where I've made use of the string labeled indexes. Now if I do this, then it will access this data because these indexes are integer, and this is also a probable label for lock to access. So it has printed all the three values, and you can see here that it has included the 2 as you're getting three values printed here, right? If I use iloc, you can see I'll have only 2 values. But don't get confused that iloc is using position and lock is actually checking whether this named index is present or not. Then I'll show the value until what? Till 2 have been asked to show the value, so I'll show it there. In iloc, the thing is I'll start from the beginning because 0 has been mentioned, and I'll print the rows till the position n minus 1, which is 1 in this case. So now we have this second data frame where I had mentioned the integer indexes, right? Now if I do this here, then what do you think will I get the value as? Okay, let's see what we get the value as. So here you can see that 0 was not present, so that's why it is not printed, but 1 and 2 were present here. So it has printed these two values here. Okay, and this is the main difference between ilock and lock, that it will print the data based on position and it will print the data based on the labels. And to clear your doubt even more, I have this another different data frame where the indexes are not even in the increasing order of the integer numbers. So here, let's have this data frame printed. Yeah. So I have this data frame. You can see the indexes are in random integer order. So the ordering of the numbers are not correct here. Now what if I try lock here? So if I try a lock here, you can see that I have given it 0 to 4. So it matched the values with 0 index and printed this. And 4 is also included. So it looked for 4 and printed it. So that's why 0 and 4, only these two were printed. Please print 98 line for ILOC. Okay, do you mean this one? Okay, so I used ilock here and you can see that I got first and second, which is by default the positions at 0 and 1, index position 0, 1, right? If I used lock here, you can see that 0 label was not present here. So it did not printed anything. I mean the index with 0 is not present here, but indexes with 1 and 2 are present. So it has printed those two. And you know in lock the last element is included. So that's why these two were printed. So here the output of ilock and lock came out to be same, but if you go here, then here for lock and ilock came out to be different. So that's why I was saying that is the difference between lock and ilock. And to add more, this is the extra part which will clear your doubt even more. So here you can see I have my data frame with the random integers as the index. So it matched with 0, and then after that 4 was occurring, so it has included 4. This does not mean that it is going to take data for 0, 1, 2, 3, 4. It is just going to take data between the labels 0 and 4. And for simplicity, I had made use of here in while doing LOC, I had made use of this, right? So this was the labels of the indexes R1, R2, R3. If I do this as R1 and I do this as R3, you can see I get an empty data frame because R3 occurs after R1. So there is nothing between R3 and R1, but there are rows between R1 and R3. That's why these are printed. So similarly, when I make use of lock using integer indexes, it was just checking whether 0 is present and whether there is more rows between 0 and 4, both included. So here I have my fourth index, and that's why only these two were printed. If I do a 3 here, then I would get all these three values present. Okay. But if I do an ILOC, okay, then I would get the first three values presented: index 0, index 1, and index 2. So that's why when we have to access data using position of the data, we use ILOC, and we want to access the data using the labels of the rows, then we make use of LOC. So this is one of the difference, and as you can see, if I make use of this, then what would happen? You can see I'm getting an error here because two indexed row is not present here. So it cannot access the row, so it cannot reach there. Okay. But the starting index row was also not, starting index row is present here. After that, you don't have the second row present. So that's why it's giving me an error. But in case of ILOC, I will always get the values present at the index 0 and 1. As long as a value is present for that position which I am mentioning in ILOC, I will always get the data for it. Now this is another example of LOC that I had mentioned 4 and sliced it with 3. So it has matched it, and that's why these values are being printed. Unlike the previous example in which I showed that I was doing accessing from row 1 to row 3 and R1 to R3 and then R3 to R1. So one of them failed, right? So the presence of these indexes of the rows matter here. So this is the difference between these two. If you have any doubts regarding lock and ilog, you can ask me. I think I have cleared all your doubts by now. Yeah. So let's head on to IX. Now this is another indexing feature which uses both iloc and lock indexing. It is a mix of both. So it supports mixed integer and label based access. This is from the official Pandas documentation. So you can go through it in detail from there as well. So it supports both features of lock and ilog, and it primarily supports label based. So what that it means is that if uh, if you have an integer based data, it will access it. If it's not able to access it using ilog, it will prefer the lock feature for it. So I'll show you by example what do I actually mean by that. And that is also one of the reasons why it is deprecated and why it is advised not to use. So its feature is also the reason for it being deprecated. So I have my 4 data frames here, one with a labeled index, string index, one with default indexes, one with which I have specified, and one with random numerical indexes. So I'll just print the first data frame. Now I want to access the row R1 to R3 and column C1 to C4. Pretty simple, right? This is what we used in LLOC LOC for our accessing of data. You can see we were able to access the data pretty much very easily. It was just the same as LOC. Now if I use this, then what would happen? It is the same data frame DF which has the string indexes. You can see it has accessed that data as well. So here it made use of the feature of iloc. Here it made use of the feature of lock. So this is what the mixed feature of lock and iloc was as written in the documentation. So it has accessed 0, 1, 2, 3 rows by position and C1 to C4 by their label. Okay. So this method seems very I mean, the combination of both you have, so it would seem very easy to use, right? Why make use of iloc and lock separately? But I'll let you know the differences later on here. So this is my second data frame where I have the row indexes as default. So here I have accessed them normally without any difficulties. No problems here. And I can specifically uh, allot the columns as well. So this is the same as accessing using iloc. Okay. Now I have my third data frame, and this has your indexes starting from 1 to 4 and your column C1, C4, C1 to C4. Now here I access the data. So what it did here was, okay, I'll change this value. So you can see what it did here was it made use of the lock feature here. It might seem confusing to you, but it actually made use of it made use of iLock here. So 0th position, first position, and second position values were accessed. And if I print this, then you can see that it is accessing this. So now we'll have a problem when we have this data frame. Now I have this data frame where the indexes are not mentioned in order. So if I do this, then what will it follow? Will it follow the iLock? Will it follow the lock? So we try to print it, and you can see that it has followed the lock notation. So here you could not identify which feature it will follow. So that's why this problem occurred, and it followed the lock. So this is what was written in the documentation, that whether for in layman's terms, whenever there will be confusion that which method to use for indexing, it will go for the lock. So that's why it has printed using the lock indexing and not the position of iLock. And due to this confusion, you can already know that the developer would get very confused by using IX. So that's why it is deprecated and it is advised not to be used. So the same as I mentioned is, since it will be very confusing, so slicing would cause unnecessary confusion for the developer. So yeah, so let's head on to how to deal with missing data in a data frame. So now here I have a data frame where I have my first column having these values, my second column having these values, and my third column having these values. Now my here np.nan means there is no value, not a number. So on printing my data frame, you can see that not a number, not a number, not a number. I don't have any numerical value present there. So the first thing is that I need if the method to check whether my data frame has missing values, is NA function is used. So it would return a true false kind of matrix, and it would give a false for that cell value if it is not a number, and if it is a number, and true if it is not a number. So here all these true values indicate that the values are missing. I have missing data. So this is for the complete matrix. Now if I want to show column wise which NaN values are not, which NaN values are there, by that I mean which missing data are there. So here it is indicating column wise to me that C1 has a value, C2 also has value, but C3 does not have. So by false it means that not even a single value is missing in that column. Okay, so even if one value is missing, it would give as true for the columns. Okay, and you can also uh, drop the NAs if you want by making use of drop NA function. So what it does is it will drop all those rows which have missing values. So here I had only one row which does not have any missing value. That's why the result of this is the data frame with no missing value. Can we write conditional statement in data frame to find the position where we have NaN? Yes, we can have that. See, this actually gave us the matrix, right? So we can, if we have the true false values to us, we can make use of it to access particular data of the data frame also. So that will not be a problem. You can have it for a simple value as well. And for a single value, I had already mentioned that in the NumPy class. So you can go through that class to know how to do it for a single value. So because I don't want to actually repeat the same class again. Okay. Yeah. So yeah. So by default access is 0, which is for a row operation, but we can also define the axis as 1 if we want to drop the data frames according to column wise. So here we had already known that only C3 was a column which does not have any missing value, and hence it was printed. Now we can also give a threshold that how many values it needs to check for missing. So here I gave a threshold as 2, that if uh, two values are missing, more than two values are missing, then you can drop those rows. So here you can see that this row has two values missing. So that's why that row was dropped and the rest other rows were kept. So you can also make use of these thresholds. You might have many functionalities to be implemented on some CSV data where maybe more than 3 or 4 columns are missing, and there is very little you could do to deal with missing data there. So you can just keep a threshold that since that data is not useful to me, then I can just drop it using this threshold value. Now how to deal with this missing data? So here we have dropped off the missing data which was not that useful to us, and but we still have some missing data and we want to deal with it. So how do we deal with this? So we have a fill in a function by which we can use and we can fill the values. So here you can see that 10 was filled in the places where the values were missing. We can also have different values, like we have many operations like min, max, standard deviation. I'll just show each one of you. We have the standard deviation, min, max. We can have the count function. We have the mean function also. Here axis 1 means the row wise mean, okay, and axis 0 here means the column wise mean operation. So I'll show it to you as well. If you keep the axis equal to 0, it will give you the column wise mean as well. So here while calculating the mean, it did not uh, took care of your any missing values. So you can see that my DF has missing values, but while calculating the mean, it skipped those values. So that's why the mean for C2 here is 10, which is just a single value. So obviously the mean will be the value itself. And you can also go for the row-wise mean calculation. So this is one. And then you can fill the data accordingly. If you want to fill the mean, or if you want to fill the mean by column-wise data, row-wise data. And this is the minimum. So it is giving you a minimum of all the column-wise data. So I think similarly here you can make use of access also. Yeah. You can similarly make use of access here as well to get it in row-wise format. It depends on you how you want to have the data. So in standard deviation, column-wise, it is giving me an error, not an error, but an NAM for C2, because for C2 it has many missing values due to which it cannot calculate. And similarly, we have the max function, we have the count, that in C2 only one value is present, rest all are missing values. In C3 all 4 are present, and in C1 only 3 are there. We also have the describe function, which will give you all of these values to you. So this is here it is giving you column wise. You can similarly have the access to get it row wise. You can also do a transpose of it to have the columns here. This is just a simple matrix transpose, converted all the rows to columns and columns to rows. and you can just see how your data is actually according to all the metrics present. So this is all regarding the you can say operations or filling of missing data. Now we'll head on to the comparisons of data and how to query through our data, and we can also group our data. So I'll just have an example of a simple data frame here, and suppose I do a simple condition here that df1 should be greater than 5. So it returns again a true false matrix to me, stating that these true means that the data is greater than 5 here. And if I want to see what data is actually satisfying this condition, then this is the notation for writing it. So inside I have my condition, and then I want to access the data which satisfies this condition. So here you can see these all data satisfy the condition, and rest all are NaN because they do not satisfy, so they are shown as NaNs here. Now you can also do certain things, like if the data is less than a certain condition, then I want the data to be changed. So I can do that as well. And just a second. Okay. Yes, I'm sorry. Yeah. So here I use the condition that if the data is less than 5, just make the data 0. So here I have zeros as replaced value for that, and I can have the condition for a specific column as well. So it would return a true false matrix. This is just a series as we have already discussed, and then we can make use of this condition to get the actual values present. So here C1 is greater than 5 and here C1 is greater than 5. That's why these all values are printed. We can also access a particular, if a particular column after granting this condition, just make use of that indexing. You can do it. So here you can see I've accessed a single column which is C1 and I got the data for it. And I can also have one or more than one columns to be accessed using this. If I want to access some particular column, I wanted to access C1 and C3. So I can make use of this notation to access that data according to my condition. And even I can add two conditions to get my data. So here I'm adding a condition that C1 should be greater than 5 and C3 should be greater than 1. So I'll just print the data frame here. Yeah, so you can see that C1 should be greater than 5. So C1 is greater than 5 here for 8 and 12, and C3 should be greater than 1. So C3 is greater than 1 here, here, and here. But since an AND condition is used, so only these two values would be printed. And that's why these all are printed. If I'm not wrong, I think an OR condition can also be used. Okay, maybe OR cannot be used. Yeah, so you can have AND condition and you can have the values printed to those. And you can also assign the new data frame using this condition, and then you can print the data frame. So all these operations which we did not make changes to the original data frame. Only this operation made the changes to the original data frame because we are assigning the value to it. Other than these were just comparisons and the displaying of data. So if we want the new data frame to be saved, we can save it to a new data frame after applying the condition and then work on the new data frame. And suppose this new data frame now has indexes 2 and 3, but Now, since I have this data after applying a condition, the indexes are taken from the original data frame, but I want the indexes to be reset. So we have a function called as reset index, and I'm using in place equals to true so that it makes changes to the original data frame, which is my df new itself. If I don't make use of in place equals to 2, it will return a data frame and then I'll have to save it into another value. So that's why I did this. And then you can see that my indexes have been reset. I have an index column present, but these are my indexes. Okay. So you can see that index is a column here, but the real indexes now are 0 and 1. Okay. Now suppose I want to create a new column, so I can make use of this as well. So I did a split of the string and I got a list. I can also assign it to a new column. So I have a column named as new. I assigned it these values. So now you can see that new column has A and B mentioned here, right? So now I want that this column which I've created, the new column, should actually become the index for it. I don't want a numeric index. I want something which is specifying something. Basically I want some character or string as the index values. I want some labels. So I created this column new, which has A and B value, and then I'm setting it as an index using again the set index function, and I've mentioned new column. Take the new column as an index. So after applying this function, you can see that the new column has become my index now. And while accessing the index column, I'm getting this. So my new column is the index now. So, and you can definitely use LOC to access it. You can see I made use of LOC. I specified A as this is the new index now, and I got the value. Now if I use ILOC, I'll have to mention 0. So I'm getting the same result using ILOC, which is using the position. Now we have the where and mask function. So the difference between where and mask is that where method is applicable when the condition is when the condition is false or it is not satisfied, and mask is used when the condition is true or it is satisfied. Apart from that, there is no big difference between where and mask. And also you can actually tweak your condition or your data accordingly to have only where or only mask to do both of the functionalities. Suppose I have a normal series which is ranging from 0 to 4. 0 to 4 because it is using range, so n minus 1, 4 till 4 data it will have. And I used the where clause here, saying that s greater than 0 I need. So it has given me the data here. Now if I do the same for it, I will get this as this. So here s greater than 0 was not satisfied by the first element, so that is why it is an NaN. But here only the first condition satisfied the condition here, right? So that's why all others are NaN. So here these all conditions were satisfied, so I have the values present here, and the opposite of the where is done by mask, and that's why I have these values present here. So now let's do this on a simple data frame. Now I have this data frame with these values present. Now I have a simple condition which is df mod 3 should be equal 0. So basically the number present in the data frame should be divisible by 3. So 9, 6 and 3 would be the values which are divisible. So that's why these three values are coming as true here. and obviously 0 also, so that's why 0 is also there. Now I can use this condition in the where clause. I can specify this as a condition. Here we had written the conditions ourselves. We can also save that condition in a variable and then pass that variable. And then we can print our data frame. So here you can see that when I'm doing minus df, you can see all those values which are not satisfying the condition are having their values changed according to the uh, parameter I have provided here. So what it is doing, that it is checking for this condition in the data frame. If the conditions are true, then it is not making any changes. If the conditions are not met, then it is making these changes here. Okay. And if you make use of mask here, then what you can see is that it will check for the condition. If the condition is satisfied, then it will make those changes as specified on the second parameter. And if the condition is not met, then it would leave the data as it is. So this is the difference between where and mask. And similarly, as where is present in NumPy, it is present in data frame as well, which we have already gone through. And as I've already told you that we can achieve the same functionality of where and mask if we tweak our data a little. So here my condition was M, and that's why all of these values, as you can see, are coming as negative because these conditions were fulfilled by only these values, the M condition, and the rest were not fulfilled. That's why they changed. And here I wanted to achieve the same functionality of where using mask. So what I did is I used the not of M. So basically not of M means the opposite of that condition I want. So since my condition has been changed to opposite of it, that's why I'm able to achieve the same output as a where clause. So that's why I told you that you can have the same functionality of where and mask by tweaking the parameters a little. So after this, we have our query and group by. So if you have any doubts regarding where and mask and the filling of missing data, you can ask me, or else we'll just head on with the next topic. I think, yeah, then the last topic would be our concatenation, append, merge, and join. So I know we have already gone above the time limit. Okay, so just let's head on with the query now. Now, suppose we have a data frame which is having the column as this and some values, random values I'm providing it. And I will just check whether this query holds on or not. Before that, I'll just print the data frame to you. So this is what my data frame is. So my columns are A and B, and these are all the values which I have present here. I have asked for 10 values using np.random, and that's why I have 10 values here. Now I want to do a query where this A column is greater than B. So we make use of the query function here, and you can see that we got the values as at position 0 and 3. So at position 0 and 3 we have the values where A is greater than B, and that's why these two are printed. So just like your simple comparison operator, query function can also be used. You could have also done the simple way using this, and it would generate the same output to you. So it depends upon how you want to proceed on with your coding. So there is no restriction using any one over the other. And yeah, so suppose now we'll see about another example. Suppose we have this data frame here, and I'm querying where the index is greater than A and index is equals to B. So what this means is, by index, it actually does not mean the column name, it just means the index values. So that's why query gives a little more benefit than your simple comparison. So here I'm accessing these values where index is equals to B and index should be greater than the values of column A. So here I am getting those values. Here you can see the index is greater than equal to B, and the index values here both are greater than the values of A. So these are some of the applications of this query function. I'll also show you using another data frame. Suppose we have an employee data frame where we have 4 employees which have some ratings. Maybe any employee rating, we have ratings 1, 2, and 3. Now I want to query through this data frame and have the ratings where the rating 2 is greater than 1 and rating 3 is greater than 2. So we can just simply use the query function and apply this, and we can have the output. And this query can be reduced to this as well. This is supported in the query function. So you can see that the output of these two are coming the same. And we can also use the in function to specify that query only those data which are present, which are having these values present. So if some of you have the SQL background, then I think it would be even more easier for you to understand. This provides some SQL-like language support to it, to data frame querying. So you can see that rating 3 should be present in these 3 values, any one of these 3 values. So here we have 99 and 100. So these are present here. And you can see in the complete data frame only 95 and 97 are others. So that's why only these 2 values are printed here. Now we have a group by clause. So in group by, suppose we have this sales data frame which I have created. We have the location, we have the name of the salesperson maybe, and the sales which they have made. So I can have them grouped by according to a particular column. So here I'm giving the column as location. So I've grouped it and saved it in a variable. So you can see that it has been saved as a data frame grouped by an object present at this. So you cannot see any values here until you apply any aggregation or any method to it. So just like in SQL queries, we have a max, mean, min, anything of it, and then we have it grouped according to any of the columns. The same functionality we can provide in data frame as well. So now I'm applying the mean function on it, and now you can see that it has grouped the data according to locations and then given me the mean of it. So when I applied this function, it only took the numerical column which it could identify out of all these columns. So it identified that sales is a numerical column and proceeded on with the mean of it. So you can see here we have Mumbai as 2 values present here, and the mean of it has been printed here. So the mean of these two has been taken. Similarly, we can have the max, we can have the min, we can have the count as well. So in min max, it did not take in numerical columns, it just took out all the columns, unlike the mean, because mean is specifically for numerical data. In max, what it took is, if suppose for Mumbai, there were 2 values, right? Rajni and Rani. So the one which will come out to be as greater. So Rani, if you compare with Rajni, will be a bigger value, which I'll show you to you right now. Yeah, so it is giving me a true, right? I think this we have done this in string comparisons as well. So that's why Rani is printed here as the max value. And in sales, you can already know it yourself that the maximum value out of those columns would be printed here. The same is for min. So Rani was the max value. That's why Rajni is coming here. And then you can have the counts also. So location wise, Mumbai has 2 salesperson as particular to this small problem that I've created, and others have just 111. Similar to data frame, we have in group by objects also we have the describe. So you can have all of your data printed here, the count, mean, standard deviation, which will be according to the location. So this was about the group by. Now we'll head on to the last topic of our session, which is concatenation, append, merge, and join. So concatenation and append are pretty much, I mean, append is basically one particular specific use of concat, and similarly join is one specific version of merge. So I'll just go through it and tell you what the basic difference between the two is. I've created these 3 data frames. I'll print these 3. I have this data of data frame 1, which is A1, B1, C1, A2, B2, C2. Similarly, I have data frame 2 with A3, B3, C3, and A4, B4, C4, and the data frame 3. So you already know that the data of all these 3 data frames are different. So concat, what it would do is it would join all this data and give me the, sorry for using the keyword join, but it would basically add up all these data and give me a resultant data frame. So what it did is it took the data of df1, then you can assume that it added the data of df2 below it, then it added the data of df3 below it. So this is a functionality which is similar to, you can say, a union in SQL. If you have SQL background, if you don't have it, then you can just basically understand it using the simple uh, explanation which I gave it to you. And here again we have access as well. So if we change the access to 1, then we can have the data added in your column wise format as well. So here you can see that the data is added in column wise format. And if I try to access a column, then you can see that I have accessed all 3 A's because the column name is same, and I did a concatenation using column wise. So by doing that, I got same column names appended, and but while accessing, since all of these 3 are same values, same column names, so it has printed all 3. So I cannot have just one first column printed as well as it is. So this functionality can be actually useful when we have different column names maybe. So similar to concat, we have an append. So what append does is it is a simple functionality that df1 dot append df2. Okay, we have a question that row index values are similar now. How to handle it? For which of the here in the first one or in the second one of concatenation? I mean the axis equals to 1 or axis equals to 0. Can you let me know on which line number, the 210 line number or 2141, which you're asking me? If you're asking me for, yeah, 2101, then you can make use of reset underscore index. Oh, sorry. and then you can have your indexes reset. So that won't cause you any problems. This we have already discussed earlier actually. So I'm just mentioning it again because you have asked this question. You can have your indexes reset here. So now basically you have a new data frame, a fresh data frame with normal indexes, and you can also actually give string indexes according to your need. That also I've mentioned earlier in the class. So yeah, let's head on to append now. So here what append did is it added the data of df2 to df1. So you can see it has been added, and I made use of ignore index equals to true so that the index will be reset on its own. If I don't do this, then you can see that the index has been not reset here. So this is just the basic difference. But you can see that this functionality is already provided by a case of concatenation. Right, concatenation did this, and I did a reset underscore index to get the same resultant. So that's why append is actually one particular specific use of your concat itself. So this is a little two-liner about it, that concat gives you the flexibility to make join data or add data according to rows and columns, and append is a specific case of concat. Okay, so that's why I told you that append is a specific case of it, and the same is for going to be for the merge and join as well. So suppose I have this data frame df1 and df2, and I'm going to merge them on these two columns. I mean, both of them have a columns, and I'm going to merge them. And there is a how keyword parameter as well. How indicates that which kind of join you want to do. So if you don't have SQL knowledge, then it would be a little difficult for me to explain it to you. But basically, what uh, different types of joins are, like inner, outer, left, and right. So what inner does it, that it will check the column of the data of a column in both the data frames, and if they match, by match I mean that if they are equal, then it would print. But as I have already shown you that all the three data frames are different data, so that's why the resultant is nothing here. So I made use of outer join here, and you can see the data has come out here as well. So even though the data did not match, so it gave me a resultant where I have B and C, NaN, NaN, and I have B and C of the first data frame as NaN, NaN when I have the data for the second data frame. So this is how it has worked on it. I can also give it I gave a list of columns here as A. I can just specify a single A that means the same itself. But if I want to make, if I have data frames with different column names, suppose the A column of data frame 1 is actually corresponding to the B of data frame 2, then I can specify it using on. So this is how the merging would be done then. You can see whatever data frames I'm mentioning here are occurring only once, because those are the key column names on which the operation will actually be done. So that's why. Similarly here the A had not been changed. So all the data was merged for it, but the rest were not merged. Like this is your data frame 1, and B and C values are not equal to B and C of this. So that's why this is the data added here. And similarly we have this data of df1 which does not match with this data of df2. So that's why we have this resultant in the outer. And yeah, we can also have as this specified without any mentioning any column on which we want to do. And you can see that this is actually similar to our concat. So it just merged all the three columns of both the data frames and gave us the output of it. So this is one special case of concat itself. Now we'll head on to the joins. So in joins, we specify a data frame, then we specify the join function and the second data frame. So by default, it uses a left join. And we always need to specify these because in case the column names are matching, then it would give us an error. So it needs these to uh, specify the names of different, to specify differently for the column names. As here it gave it on its own, but here we need to specify for the columns. So you can see this is the first data frame, this is the second data frame, the left data frame and the right data frame. And we did a join of it. This was basically a left join. And we can do your right join as well just by displacing the data frames. So the df1 which was present in the left side, I have put it in the right side, and we are similarly getting your output here. We can also specify what kind of operation we want to do. So suppose I'm giving an inner join here. So I did an inner join, and I can also give it as an outer join. So the only difference between the join and a merge is that, again, join is a special case of merge. So what this left dot merge will do is similar to what your join is doing. So in left dot merge, we have some indexing parameters which we can specify. So I'll just show it to you as well. Maybe that will clear it. Yeah. So see, the merge function did the same thing which the join function did. It's only that the number of parameters that I've allotted to it are different now. So that is why the join is a special case of merge itself. So you can achieve merge functionality, join functionality using merge only. The difference is that join occurs on index and merge usually occurs on column or multiple columns. So here I had to specify to perform the operation on indexes by giving these parameters, setting these parameters as true. That's why it gave me an output similar to join. So this is the difference, and also we have a way to achieve the same output as join using merge as well. So that's all from my side. If you have any doubts, you can ask me. For merge, join, and append and concat, I can understand that you might have some confusion right now, because unless and until you do some hands-on, you will definitely have doubts on this. I'll share a link regarding this as well, and also I'll share this notebook with you guys. Yeah, I'll definitely share this code with you guys so you can have hands-on experience of it. So if you have any doubts, you can ask me on group by, query, concat, merge, any of these topics. Okay, if you don't have any doubts, then that's all from my side. We can end this session then. Thank you guys.